Okay, so in the previous video we saw how we can look at a graph to be able to see if it's direct or inverse variation, and if it is direct variation, to determine if it was in the form y equals k times x or k times x squared. So if it was a straight line, we knew that by looking at a graph it's in the form k times x. If it was a curved line, it looked like a parabola, it was in the form k times x squared. But remember, we mentioned the fact that it's not always easiest by looking at a graph. And so we looked at a second example that what we did is we didn't look at the graph and we just used another method to come up with what form the general equation is, which is what we're going to have to do in this case. If we look at just the table, you can see, looking down your column here for W's, as the weight increases, the value for D, the distance, is going to decrease. And this is dealing with the teeter-totter example. So the heavier the person weighs, the distance away from the pivot point is going to decrease. And by looking at the graph, we can see that we don't know if it's in the form k divided by x or k divided by x squared. So this is where using that other method is going to be most helpful. Now, they're going to use this phrase. They're going to say, use the fundamental theorem of variation to determine an appropriate model that relates the weights, blah, blah, blah. When they say use the fundamental theorem of variation, that's what we were doing in that second example that we did in the first video. So let's look at how we do that in this one. Again, we know that it's in the form y equals k divided by x, but we don't know what the exponent's going to be. So that's what we have to figure out. Now what I like to do is I like to pick a number like 70, and I say, well, if I double it, is that number on here? If I triple it, is that number on here? Well, 70 times 2 gives me 140, and that is on here. We'll look at an example in a minute if it's not on there. But remember, this is inverse variation, so whatever happens to the x, the opposite happens to y, to the nth power. So if x, or in this case the weight, is doubled or multiplied by 2, the y, or the d, is going to be divided by 2 to some exponent. We want to figure out what the exponent is. Well, if I take 1.7 divided by 2, I end up getting 0.85. If I take, which is really close to 0.9, but it's not exactly 0.9. What you need to remember is what we're coming up with is a model. A model is not always going to be exact. It's going to give us a really close answer most of the time. Sometimes it's going to be exact, but in this case, 1.7 divided by 2 does not give me exactly 0.9. Just to confirm that it's not going to be 2 squared, if I take 1.7 divided by 4, I end up getting like 0.425. So it's not going to be 2 squared. That tells me it has to be 2 to the first power. Meaning my equation is in the form y equals k divided by x to the first power. But specifically for this equation, we're not using x and y, we're using w and d. So I'm going to say d equals k divided by w. But that's not my answer. My answer I'm looking for is what's a specific variation equation that would give me all of these numbers in the table and would help me predict numbers that are not in the table. So to do that, I can pick any pair of numbers here. It doesn't matter which pair I use. So let's just say I use 100 and 1.2. What that means, I'm going to put replace w with 100 and d with 1.2. And when I do that, I'm going to multiply both sides by 100, which gives me k equals 120. Now, you might have used a different pair of numbers here and got a different answer than 120. It's usually going to be right around this number. So there are going to be times where there's more than one answer you could get for k, but they're all going to be off by maybe just 1 or 2 units. Because if you use 70 and 1.7, for example, you end up getting 119 for your value for k. And that's okay. The idea here is that we're coming up with a model that's going to give us close to these answers. So now I can write down what my specific equation is going to be. It's going to be d equals 120 divided by w. There's my variation equation. That's what we're looking for. So now I can use that to make a prediction for other heights by just plugging, by other values for d. I can just plug 90 in for w, take 120 divided by 90, and that would give me my answer. Which we're going to skip that because I just want to get to the end here. I want to look at this last example. Remember, our first step is figure out, well, is this an example of direct variation or inverse variation? So as I look down my x's here, they're increasing, but I look down my column for y's, those are decreasing. So it's an example of inverse variation. It's in the form y equals k divided by x to some exponent. So we need to figure out what the exponent is, but if we use the 60, if I take 60 times 2, it's 120. It's not on here. In fact, 60 times 3 is obviously 180. It's not going to be on here either. So now I'm in this predicament. If you're in this situation, you use any pair of numbers. It does not matter. You're going to get different numbers to begin with, but the idea here is you're trying to figure out what the exponent is. So that's why the numbers don't matter. So let's say if I use 60 and 75. I want to figure out what times 60 would give me 75. If you're not sure, take and divide these out. If I take 75 divided by 60, I get 1.25 as my answer. So what that means is that I'm multiplying by 1.25 here. 60 times 1.25 gives me 75. I want to use that. Remember, this is inverse variation, so whatever happens to x, the opposite happens to y, to some exponent. I want to figure out what that exponent is. So if I take 2.5 divided by 1.25, I get exactly 2. So that tells me that my answer would be 1.25 to the first power, meaning that my exponent there is going to be 1. So y equals k divided by x, and that's what they're using here is x and y's. So I'm good to go as far as my general equation. Now I get to pick any pair of numbers here I want to figure out what k is. It doesn't matter which pair of numbers I use, so I'm going to use, let's say if I use 75 and 2. If I use 75 and 2, I'm going to put 2 in for y, so it's going to be 2 equals k divided by my x, which is 75. Multiply both sides by 75 gives me k equals 150. So to find the equation, it's going to be y equals 150 divided by x. Again, you should always double check your answers. Like if I were to take 150 divided by 91, I'm going to get really close to 1.65. So that tells me that I'm doing it correctly, that this is a good model for this situation. So if I wanted to figure out, if I want to predict the value of x when y is 100, for this one I would put 100 in for y. So to solve this, it's kind of strange. I have to actually, I want to get rid of the x, because remember you want to get rid of the fraction. So you're going to multiply both sides by x, giving me 100x equals 150. Now I divide both sides by 100. Give me 1.5 as my answer. So you just always want to make sure that you're careful. Make sure that you put the numbers in the right spots. When they say find x when y equals 100, make sure you put 100 in for y. So hopefully now you have a better understanding of how to do these problems. Lesson 2.8 takes this another step further, so we'll have more practice with this in the next video.